Art and Science in the Portuguese Renaissance. And now we are going to begin with my good friend, SAMUEL GESSNER, friend and colleague here from the Interuniversity Centre for the History of Science and Technology. So SAMUEL GESSNER is an expert on everything that is related with the early modern science and especially material culture. He has been a research fellow here for a long time as a postdoc, and now he has a position of auxiliary research. Is this the name? I know that it is investigador auxiliar, but in English it's a little bit strange, but okay. And so he has this contract now with the faculty, so he's going to be with us for more 6 years, which is a great honor and pleasure. And so he's going to present Fazendose Cada nesta Cidade Globos Muito Fermosos e Custosos, Pedro Nunes on the art and science of making terrestrial globes. Okay, thank you. The floor is yours, Samuel. Thank you so much.
Thank you so much, Anna. Thank you for your very kind introduction. It is indeed a pleasure to be here with these illustrious participants and keynote speakers. Thank you so much to the organizers for having brought this together, also in homage to Helena, Avelar. I will talk about Pedro Nunes, and this is perhaps a certain risk, because in the audience I can see there are several specialists, world-leading scholars about Pedro Nunes, and I'm afraid I won't add very much substantial new stuff about Pedro Nunes. What I want to try to do is to shift the attention on some of his writings and look at what Pedro Nunes said about globe making. So Pedro Nunes was undoubtedly the most important Portuguese mathematician of the Renaissance, and he has made significant contributions to mathematics, of course, to the science of navigation, of which I will talk a bit, but also to algebra and to applications of spherical trigonometry. He was just a great master. And so Fazendose Cada nesta Cidade Globos Muito Fermosos and Custosos, you can translate this as, you know, in the city, beautiful and expensive globes are made every day. And so one can ask, actually, why did Nunes spend time to think about globes? So Pedro Nunes was trained at the University of Salamanca and in Lisbon. He lectured at the University of Lisbon on philosophy, and while he was still training to become a doctor of medicine, but fairly early in his career, he was called to the king's service and as a cosmographer around 1530, and also as the teacher of the king's João III's brothers, first Don Luís and then Don Henrique, and together with these quite probably also other noblemen, moços, who were at the royal court there, so to teach them what they would like to know. And apparently they were curious. Some of them were clearly curious about mathematics, astronomy, but also navigation. And so why would Nunes spend time and effort to explain things about globe making, you know, as as a mathematician. His historiography has shown his important contributions to theoretical questions. So he was, especially he was the first mathematician who conceptualized the concept of a very special curve, the loxodromic curve. So it's a curve in 3D that you can trace on a globe, you see. So it corresponds to the ideal trace, the ideal path a ship would navigate if it keeps its constant course, geographically speaking. And so this is not, he showed first that this is not a great circle. It's different in most cases from a great circle on the sphere. And he characterized, he established the properties, some fundamental properties of these loxodromic curves or rhumb lines, as you know them. So there is a history of mathematics of these results, you know, what has been achieved by mathematicians. Now, for several decades already, historians have become more and more interested in looking at the history of mathematics as a history of practices, and it means so to understand in the actors, from the actors' viewpoints, what their options were, what their techniques, what their tools were. And this is an ongoing project for me. I want to, and so there won't be time to kind of give an extensive talk about Pedro Nunes' mathematical culture, the methodologies he was formed with, the principles he accepted, his epistemology in a certain sense. Also, there's no time, and I haven't done the work yet. So what I'm telling you today is just the beginning of kind of citing the material, where to look, what to observe. And of course, I will heed Henrique's suggestion at the beginning of the workshop that this is an opportunity to meet art historians, and I very much appreciate this possible dialogue. I hope I know several of the colleagues who are here, and I really look forward to continuing this dialogue. And I also want to heed or kind of imitate the previous speakers' proposals in a way. The great concept of this demissione text that takes the reader on a journey to learn something. As I've understood, this was the intention of Duarte to write a text that would captivate his readers, so that they would learn lots of things, Latin, of course, but many other things. And so let's go on this journey together. So let me try to move on to the next slide. So I'm taking you first to Lisbon in the 1520s, and I've put this miniature on purpose, as I know that several of you will know it. It comes from a book of ours. Sorry, I'm trying to move the windows up, but I'm not able to do it. It shows one of the main streets of the center of Lisbon, probably the Rua Nova dos Mercadores, where well, we know not only merchants had their premises, but also goldsmiths and other artisans, and who knows, maybe the miniaturists and illuminators who could have been involved in globe making. I have no concrete indications about this, but I mean, Pedro Nunes tells us that there are, sorry, I really make a desperate attempt to get this window up. Let me do it like this. Sorry for interrupting. So let's look at this passage from one of the earliest printed works of Pedro Nunes, where he says, while beautiful and expensive globes are made in this city every day, that are conform to the shape of the world in which we move and therefore contain no mistake, for their lack of science, those who make them and those who commission them commit a double error. And so what does this passage tell us? It tells us that apparently globe making was something current at the time, so about in the 1530s. And it tells us, but it tells us also that Nunes took some issue with the way these globes were made. By the way, Anna, how much time do I have? Because I'm perhaps taking up much time in delighting.
You are okay. I think half an hour. There's no problem because
when should I
or 25
end?
minutes, and then we have a little bit discussion, okay, and then goes to Adeline Cardoso. I don't think there's a problem.
So I should stop at the latest at 11:10 or so.
No, 20 past 12.
20 past 12. Okay.
Okay.
20 past 12. Try to leave some time for discussion. But of course, this is a printed text. It's well known. It has been looked at by many scholars before, and of course, this comes as part of the chapter or of the book in this publication in defense of the sea chart, Carta de Mariar. And so the text is not about globes, mainly it's about the charts that were used by the pilots. But in this passage, Nunes talks about the globe making, and what error is he talking about? The double error. And he explains that. He says they're reading what's on the chart. They're reading these charts in the wrong way for the first at the first. And the second error is that when they put these what they take from the chart, when they put it on the globe, they do it in the wrong way. So they do a double error. That's my reading, although dobrados erros could also be just a kind of emphasizing the error. And so we know actually that, yes, although there's no extant Portuguese globes or Spanish globes that from the early 16th century extent, we know that there were globe makers. So for instance, Diego Ribeiro, who actually worked first in Portugal and then went into the service of King Charles V, or later the Emperor Charles V. He made also globes. He's also the author of the Mappa Mundi, or of this universal chart, of which you see an extract here. And so that was Nunes tells us the globe makers, they would take such a chart and transpose it onto a globe. And he says, well, the globes, they have the good shape. The Earth is a sphere and the globes are spherical. So there's no problem in that. And just a year after Diogo Ribeiro made this chart in Sevilla, the other end of Europe, in Antwerp, Gemma Frisius published another print work about the foundations of astronomy and cosmography, and about the use of the globe. Gemma Frisius was already a famous publisher by then, because he has re-edited and adapted Pedro Sappiano's cosmography book. But in this book, he kind of gives another summary or reshaping of Appiano's cosmography, and adds chapters about the use of the globe. And if you read on this title page, on this title page, you see what the terrestrial globes in Antwerp would look like. And Gemma Frisius is known to have produced globes in collaboration with Gerard Mercator and another artisan, van der Heyden, Goldsmith, I think. So their globes looked more like this, and on the frontispiece underneath there's this writing. I put it here in small print: Veneunt cum globus Loani apud servatium. So these books are sold together with the globes in Louvain, at the shop in Louvain, Servatium Zanes, or Servatius Zanes, I don't know who that is, or in Antwerp. So you could purchase a book and a globe. And of course, in this case, the globes were probably printed globes, but we don't have printed globes from Gemma that early. So I don't know what those globes were, but there were very soon printed globes were around since the 1510 or years. And so what does Gemma Frisius was not, I mean, he's not so much known as a mathematician in history. He's more known as the publisher of these cosmographic and astronomical books. He wrote about surveying, a lot about instruments, and his association with Mercator was significant. And he, as an instrument maker, he was quite renowned. So what does Gemma Frisius tell us about how you would use such a globe? So there are in a book about the use of globes, you have several ways, things you can do with a globe. You know, well, one thing is to look up the position of a town or a port, read what latitude it is, what longitude. This is things you can even do with a globe today if you have a terrestrial globe at home. But there are other things that you could do with these globes that you would not be able to do with modern terrestrial globes. And that's, for instance, here in chapter 20, the problem that Gemma tells us is so to figure out what the direction is from one place to another. It's kind of the general question of the Qibla. You know, Qibla is the determination of the direction of Mecca, to know to what direction a Muslim has to pray towards. And so it's anywhere on earth you need to know where that direction is. And so if you have a globe, this is easily done, and Gemma Frisius shows it to you in these in this passage. So what would you do? You would tilt your globe so that the starting place is at the top, at the zenith, yes, this is the text. First, we position the mobile meridian below the mobile meridian, the place in which we are, or from which we want to determine the other place. And we make the pole of the globe be above the horizon according to its latitude. So he turns first the globe so that the place is underneath the meridian, and then he tilts the globe. And so this is a thing you can't do with a modern globe usually, to tilt its axis so that the elevation of the axis of the Earth is according to the elevation of the pole. So kind of you imitate the local position of your place. After having fixed the altitude quadrant to the meridian such that the instrument fits flush into it directly above the aforesaid place. And so what is this altitude quadrant? I can show it to you, I think here. Do I have a pointer or something? Yeah, gosh, why is my not showing? I want to.
It's working, Samuel.
Sorry.
It's working. You are showing.
Okay.
It's working.
Do I have a? I would like to have a pointer or a spotlight or something.
I think it doesn't work when it is full screen. So if you want to change,
really?
Because it was, we were seeing, and then when you put full screen, we stopped seeing.
Okay. And I can't do anything. Yeah. So it works when I'm not full screen. So very good.
Perfect, like that. Okay.
Oh, what's that? So you can see my mouse now, I think.
Yes.
Sorry for the hassle. So I can't go back. I will go back like this. Okay. So there's a device here. This is a quarter of a circle, and he calls it the altitude quadrant. It's a piece that you can pivot around. It has this foot here that slides on the horizon, and so you can pivot it around. What he tells you, put the place you're working, you're thinking of to your zenith here, and underneath the meridian circle, and then you pivot these altitude quadrants so that it passes through the place of which you want to know the direction. And then you read off the direction here. So in this example, for instance, well, our starting place is somewhere here in Eastern Asia, or Vladivostok or something very, very far away. And we want to know the direction to a place here somewhere in Vietnam, or it's difficult to tell. And direction would be due west, would be due west. And what you also see, and I'll come back to this, is that this line that goes through this direction is a great circle, and will cut the white circle here that represents the equator of the Earth. Any direction from this point is a great circle and will cut the equator. So I think I can come back to the larger view here. So that's the instructions of Gamma Frisius. Now you see the treatise Pedro Nunes writes and publishes in 1537 about the sea chart. Starts actually by counting the story of his encounter with one of the fidalgos, one of the persons at court, Martin Afonso de Souza, who was who became a famous and important captain and commander. He went on a campaign to Brazil in 1530, and he came back. And when he came back, he would confront a series of questions to Pedro Nunes, and one of the questions was a question that might sound strange to us: why, if I'm navigating along a parallel circle, why don't I ever cross the equator? The question might sound strange because a parallel circle is parallel to the equator. So if you navigate on a parallel circle, it's clear that you don't cross the equator, because two parallels do not cross each other. But the question very probably needs to be understood in the light of the teachings, like the teachings of Gamma-Frisius. If you're somewhere on a point and you trace the direction due east or due west, you will, with the globe, you will do this on a great circle, and this great circle will cross the equator. So if Afonso de Souza, Martin Afonso de Souza has learned the lesson he learned perhaps together with Pedro Nunes when they studied how to use a globe, he could easily become confused. So it was a good question because on the ship back to from Brazil back to Portugal, yes, they could he could make the experience, put the globe up and choose a direction due east, and it would cross the equator. But of course, the course the pilot would choose would not be the course due east. It would be one of the courses that you see here represented on this windrose, and you see the traditional way the navigators divided the different drums in 32 different directions. So this is somehow the origin of or the way Nunes introduces his problem is by recounting the story. Okay, I got this question from a person at court who wanted to know why this is so, and actually in his treatise he replies systematically to the questions asked by Martin Afonso de Souza. In the process, actually, he comes up with this clear distinction between the great circles on a sphere and the rhomb lines on a sphere. So the lines traced by the us. And in this edition, you end up with this beautiful rosette, these beautiful idealized figures of some of the rhomb lines. Now, what does this has to do with globes? Because I see the navigators would use flat charts, and here the rhombs are represented by straight lines. the problem comes up when you use a globe. The question, the confusion arises when you use a globe and try to represent what happens when you navigate. And indeed, although this is not mentioned in this early treatise, in this early publication of 37, there is strong evidence that Pedro Nunes actually wrote a treatise about drawing rump lines on the globe. We have indirect evidence from a second manuscript, one of the manuscripts, few manuscript treatises that have survived in manuscript by Pedro Nunes. The usual title is Defensão do Tratado da Arrumação do Globo, so a defense of a treatise he purportedly has written about the tracing of rump lines on a globe. And so we see that already before 1544, this is a terminus post antiquem, Nunes had actually written a treatise on how to trace rump lines on a globe. And if you had those rump lines on the globe, you would, this would help you not to make the confusion or fall into the confusions that Martim Afonso Sousa had. Now, there are actually very early globes that have these rump lines, and to my knowledge, the earliest version of terrestrial globes that represent these rump lines is the one produced by Mercator in Louvain. So actually the former collaborator of Gemma Frisius. And this is much earlier than the, Mercator is very known for the Mercator chart, the flat with this special Mercator projection. But here we're talking about globes, and this is more than 20 years before the chart. Mercator made globes, and he inscribed rump lines. So here we see a detail of a part of the globe somewhere south on the southern side, so that there's no coastlines, and we can observe very well how these rump lines, 32 rump lines, come out of a center. But we know that practically at the same time, and we might assume that probably earlier, before the production of this globe, Nunes has written a treatise on how to trace rump lines on a globe. We have a certain, we get a certain idea of what Nunes wrote in that treatise. On the one hand, from this manuscript Defensão, the defense of the treatise, but also because in his collected works published in 1566, there is actually a chapter on the way to trace rump lines on the globe. And these works are written in Latin, whereas the earlier treatise was in Portuguese. But we may assume that the content may have been quite similar. So in this opera, it's quite conspicuous that although Nunes does not talk only about navigation and problems of sea charts or globes, he talks about astronomy, about other instruments, about the problem of mechanics from Aristotle, pseudo-Aristotle, many different topics. But the book at the very beginning has this beautiful woodcut of a windrose, and this is a reminder for the reader who might not be familiar with this division of the winds, and also because in the Latin text the directions are given usually in the vernacular denomination, so nord-noroeste, noroeste, etc. So while the treatise is entirely in Latin, some technical terms here are in the vernacular. And so these works 66 start with 2 books about the charts and navigation. The first book is very short. It's more or less the translation of the Latin work published in 37. The second book is larger and is much more expanding the topic. And in particular, the last 2 chapters, so it's a long treatise with 27 chapters, and the last 2 chapters, 26 and 27, are exactly about the globes with rhomb lines. So the first part is the chapter 26, talking about how to trace these lines on the globe, and chapter 27 is then how to use the globe. So it corresponds a bit to what Gemma Frisius in his 1530 treatise wrote about de usu globi, but it's of course a different globe. It's especially about how to use these rhomb lines on the globe that were not there on the 1530 globes of Gemma. So what does Nunes need to trace these rhomb lines? Well, he needs to insert the globe into a meridian ring. This is quite standard. What's perhaps particular is that the numbering is different. So instead of giving the latitude 0 at the equator going up to 90, it starts the numbering starts from the axis and goes to 90 to the equator, and he calls this distance the arc of the meridian. And he also needs this, as I'm unable to point it on the screen, I'm sorry, I'm gesturing. So this sphericum regulamentum. So it's a spherical ruler. It's a bent ruler. So you have to produce a ruler that has exactly the same curvature as your globe. And that's not all. In addition to this, you need also a table. I don't know whether I introduced it well. You need a table Y. You will see. You will understand it from the procedure I described you. So this goes in steps. He would trace these lines pointwise. So it starts at the letter B here on the left hand side. Perhaps it's easier like this. Can everybody see the pointer? Okay. So here Nunes starts tracing his first rhomb. So he chooses a rhomb, and he needs to have a calculated table of rhombs. And in this table, he finds segment by segment the parts of his rhomb line. And in the table, he will find the difference of longitude of his first point, F, and he will find the length, the arc of the meridian. And so he will get these 2 numbers from the table, the orange one and the blue, and then by turning the meridian from this position to this, he will find the point F. And in the next column of his table, he will find again a new arc of the meridian and a new difference of longitude, and he will move the meridian circle again to this position, to this arc here, and he will get the second point, and so forth. And so that's the idea of a first idea of how you can trace these rhomb lines. So once you have the points, then you trace them out, and here's the table that you need. So the table is given in Nunes' books. This is a well-known story. It's in the printed editions. The numbers are not there, and Nunes says, well, this is some homework for those who need to practice computation. They can do it. He explains how to compute it, but what you see here is the orange rectangle marks the column for the arc of the meridian. Then the blue is the difference in longitude. It's measured along the equator. And then there's a third column in red that we have not looked at, but actually it's another thing that Nunes computes is the length of the great circle connecting the first point and the second point. So this corresponds, if you want, to the sections BF and FH on this red line. So the actual path. Once you have constructed the lines, then you would color them, and that's very nice. There's a little passage where Nunes tells us that you need to use black for the cardinal directions, and for the intermediate ones, green for the ones that are in between, and red for the remainder ones. But that's not all. Nunes also then says, well, you can do it in a different way. And he actually gives you 3 ways to use the table and use either differences of longitude and latitude, or the length of the path and difference of longitude, the length of the path and difference of latitude. Or you can use an additional small instrument that he calls sphericum quadrans. Here you have actually the engraving gives you an idea of what this is. This is a quadrant that is curved like the surface of the globe and has the rhombs inscribed, or the directions of the rhombs inscribed. So these are exactly 8 different directions in a quadrant. At M, you have a right angle, and you can do it of copper or of iron, as you wish. And with this, you can also, Nunes will give you instructions how to do it. He explains actually 2 different ways to do it. You can either use the table plus this quadrant, and then you would just use the length of you would trace, actually there's an image about how it's done. So you'd place your small quadrant at the first point, M here, adjust it to the rhomb you want, MQ, and then you trace the whole line from M to the extremity L. But then you don't need this whole length. You only need the length that that corresponds to the path length that you can find in the table. That's the first way. Or you can also do it in a more mechanical way without using any table. And just by there's a second picture actually how you do this. Then you would just kind of seek the place where the difference between the rhomb, you would turn the meridian and seek the place where the traced rhomb will differ from the rhomb quadrant on the meridian by 1 degree. And when you see the difference is 1 degree, then you would set a point and readjust. And so you trace actually the rhomb lines by a series of small bits of great circles. And here you see also the emergence of something that had a great future, of course. It's kind of infinitesimal, an idea of an infinitesimal division of a curve. And I will end with this slide where you see an overview of what I've just said. These two final chapters of the second book in these works. You have a first chapter talking about the making of the globe, or the rhomb lines on the globe, and you have a second chapter on the use of these rhomb lines. And there are 5 use. You could probably invent more, but these are the most obvious. And it's always, the structure is always the same. You are given a few things, 2 or 3 things, and you need to find something else. So given 2 places, find the rhomb is one. Given 2 places, find the length of the path. And it's amazing that these, the way you use, you solve these problems often are not, they're not deterministic in a way. They involve trial and error. They involve approximation, some reasoning. And this is also it's something that is quite familiar to. I need to say 2 things to end. The structure of a text where you have an explanation of the making and then explanation of the use of an instrument is the very typical structure of instrument and instrument treatise. So this is a genre of text that comes here, kind of yes, embarked into a larger book made by Nunes. And one can say that
Samuel,
what I will really end with this,
okay,
with this final sentence. So Nunes is here focusing not so much on the abstract concept that lies behind these new curves, but he presents the technological details needed for making these rhomb lines and globes. And he chooses, therefore, a specific way of talking about the mathematical instrument, and it's a way that is well known in the milieu he is addressing. In a way, he contributes with his mathematical science to the art of globe making. Thank you very much, and thanks for bearing and for the patience.
Thank you very much, Samuel. Okay, now we'll have some minutes for discussion, but not that much, as this conference was a little bit larger. So if there is any question, please. If not, no, there is probably a lot of questions, but we'll have to make it in 5 minutes, okay? So please, Henrique.
I will be very brief. Thank you very much, Samuel. This was very enlightening. An interesting topic that maybe people are not aware, and this is why, one of the reasons why this was so interesting, is that we actually know very little on how globes were really used. For example, there is a big discussion how were globes really, in fact, used for navigational purposes, where the cases that you showed was not strictly navigational, was more of a theoretical nature. But what I want to underline is that we know very little on how the real use of globes. So anything that one might add, it's always very welcome. So this is my first observation. But I have a second observation, because there were many things to comment, of course, as you can imagine. But the only observation I want to make is about your initial quotation about the errors that one commits if one uses globes and then tries to go to a chart. This is a very subtle point, but it's a very important point. And basically, without going into much detail, it means that if you use the strategy that you use to make globes And to make a globe, basically what you want is a longitude and a latitude for each point. This strategy is not immediately applicable to make a chart. Actually, charts are basically, nautical charts are basically incompatible with this strategy. And so, you know, in the 30s, in the 1530s, this type of very subtle problems began to be noted, especially by Nunes, but also by others. And basically, you know, and I will end with this, it's because a nautical chart is not made using a, you know, Ptolemaic prescription of figuring out latitude and longitude for each place and then, you know, projecting into a flat surface. This is not how nautical charts are made, but this is what's behind that observation. I don't know if I made myself clear. You know, the overall thing is, you know, it's very interesting that you presented this. Yeah, thank you very much.
You were very clear as usual, and probably helped some in the audience to make it even clearer. What I can add to this is that, yes, Nunes is clear about you should not take the lines on the nautical chart as representing longitudes, latitudes perhaps, yes, but not as longitudes. But imagine if you have a globe that has the rhumb lines, then you could use the nautical charts and the rhumb lines on the chart to put your places on the globe. And he doesn't say this, but it's me who say this, because the rhumb lines are there on the nautical charts and they work, at least for the rotas, I mean, for the actual places. And here I'm of course indebted to you and Joaquin who have taught us all this. So just we will have this conversation, a longer conversation about this, I hope.
Thank you very much, Samuel. Okay, Luís Terapicos. And then there was another question by Sylvie Devart.
Yes, well, a brief question. Why do you think that Iberian globes from the 16th century have not survived? Because we have no examples of globes.
There's
they were made because Nunes, as Nunes reported, and several other sources reports that they were made, but we have no examples. Why do you think this is the case?
They were handmade globes, and they were not. I mean, there were manuscript globes, and they were not of gold or silver. So we have early earth globes in Krakow, in Paris, that are of gold or gilt something, and we have, you know, the Beheim globe in Nuremberg that is painted. There's a few, but so the early terrestrial globes we have are mainly those who were printed, and so they were produced in many copies, and there was more chances to survive. Yes, it's a pity that we don't have any globe by Diogo Ribeiro. I agree.
Okay, thank you. Sylvie, please. You have to unmute. Okay.
It's just a question about Georges Barbouda. That work with Pedro Nunes in the 60s. Did you work about that? Georges Barbouda, Illuminador, in relationship with Don Juan de Borja, Rui Loureiro studied that. Do you know?
Samuel, you have to unmute.
Yes, I'm not aware of this. So it's
very important.
What does it regard to?
It's a historical fact. Very interesting. I work on that because I work on Juan de Borja, Don Juan de Borja, ambassador.
Yeah, João de Borba.
And there is a long story with Georges Barbuda, who was illuminating maps, and all these people were friends of Francisco de Holanda. And then I studied that, and he passed to Spain and was in jail for that. And Louis Lorero found a lot about that. You don't know, because it is important, I think, it on the story of cartography and the relationship with the illuminators.
Maybe you can speak in French between you. Maybe.
No.
Yeah.
No.
No, but this is really interesting. Of course. No, so if I understand you well.
Não conheces esta história. É importante. Eu não percebo nada de cartografia, só percebo de coisas. Não preciso de alguém que perceba essas coisas para andar mais à frente. Então, tem de investigar essa coisa, posso enviar o material, se quiser, porque
faz favor, sim, claro.
São dados históricos.
No, what Nunes is saying about about the globes, and this is what you're alluding to, that he talks about globes that are made in a very precious way. And there's a second passage where he says, well, people are happy with the globes as long as there are camels and elephants and lots of gold on them.
Yeah.
And palm trees.
Yes.
But that's not enough for him. So mean that there's that this is a kind of perhaps a private joke to some of his friends at the.
But in the reimpression, na reimpressão da obra da ópera de Pedro Nunes, ele cancelou essas partes das críticas aos iluminadores. Então, isto dá muito interesse. Há uma evolução, há uma colaboração com iluminadores, mesmo nos anos 60. E este Jorge Barbuda é um iluminador de cartografia, que colabora também com o embaixador, essa figura que tem muito interesse, e é uma visão muito ampla, que também faz emblemas, ajuda a desenhar esses emblemas. Então, e depois ele foge para a corte, vai a Sevilha, é uma figura importante a Sevilha. E,
muito obrigado.
Então, isto é estudado o Rui Loureiro, o historiador do Algarve, encontrou mais material que dá uma visão mais interessante do problema. Mas eu, tratando dessas coisas, não entendo bem, não sei ler essas coisas é demasiado complicado. Então, acho que temos de ter uma colaboração sobre essas
coisas. Vai ser agora, neste
livro.
Vai ser agora.
Seria ótimo, se nós saímos
fantástico.
Com uma ideia de...
Então, depois vou enviar, não tenho o seu e-mail, mas posso enviar os artigos que podem...
Não, mas Silvi tem, porque quando são aqueles e-mails do Art&Science, eu envio para o grupo. Sim, e também enviei para si, estão lá os dois.
Porque eu não posso tratar do problema historicamente, hein? Mas não posso falar dessas coisas de curvas e tudo. Então, é só uma colaboração, porque é estranho que não conheçam, é um português que fala nisso.
Mas é fantástico.
Uma pobre coitada de francesa a falar. Então,
He is also from Switzerland, so that's why. So that's why these meetings are so important. It's because we can exchange our knowledge with each other. Okay, thank you so much, Sylvie. Thank you so much, Samuel.